There has been one certainty across the entire history of humanity that quite literally everyone that's ever lived faced. It's death. Even taxes aren't as certain, as there have been humans in the past that had no such concept. As a result, humans throughout history have toyed with the idea of immortality and defeating death. But here, a distinction must be made. Many peoples throughout history believed and believe in non-physical immortality. That one must be left to the spiritual. But actual physical immortality within the universe may be possible, at least in a practical way. Eventually, true immortality may be unachievable, as the universe itself isn't immortal, at least in its present form. So here are 10 hypothetical ways you could end up functionally immortal, including unintentional ones where you have no choice. Number 10. Digital immortality. Digital immortality, or at least the prospect of it, is nothing new. The first scientific paper advancing the concept came out in 1971, and in a nutshell, the idea is that you could, in principle, scan or otherwise transfer the contents and operations of a human brain into a machine and thus make a copy. Alternatively, you could, in principle, gradually replace neurons in a human brain with artificial neurons, slowly transferring the information and consciousness of that brain onto a digital medium. This would in effect allow one to upload themselves into a computer. Whether it would be the same consciousness and you would remain you is still debated. However, the effect is the same either way: immortality through backup. Any number of backups of you could be made, and even allow for you to interact with your backup, as strange as that might be. But this is functional digital immortality so long as there is a system preserving your program. And as each iteration of you is destroyed, another you could be made from the backups. Or it could simply be that the human brain does not transfer and only emulations of it can be made. You yourself simply can't transfer. But in this case, it opens up an interesting future possibility. If you can't transfer and thus die, your backup digital emulation would still be around. One can envision future tombstones sporting a fully interactive, artificially intelligent representation of you for anyone visiting to talk to. Number 9. Physical immortality and cloning. Physical immortality in the sense of remaining a biological being that lives forever is a truly ancient idea, perhaps originating in the early days of human prehistory. After all, it's easy to imagine someone that simply doesn't die. But actually defeating the aging process and preventing natural death eludes us, and it comes with two problems. The first is that, statistically speaking, the chances of you having a fatal accident eventually catch up with you after about 10,000 years. You can live a long time, but chances are at some point you get vaporized or hit by an asteroid. The other problem is that we simply just aren't designed for immortality. That said, we have been fairly successful at extending the human lifespan. Our prehistoric ancestors were for the most part gone by age 30, and even just 300 years ago, hitting 50 was somewhat uncommon. Some have suggested, however, that some people alive today will catch a curve of life extension technological development and may still be here centuries from now, so long as the technology continues to develop from there. But getting to biological immortality is the key. One way is cryonics, essentially freezing yourself, along with vitrification agents to protect your cells, and then staying that way indefinitely until whatever killed you can be cured, the damage to your body repaired, and then you can be woke up. If you wake up at a time where biological immortality has been achieved, then you've made it to immortality simply by trying to survive a disease. Presumably, any attempt to wake up a frozen time traveler would involve nanotechnology that can repair a body from within. This would be all important because when you freeze someone, it doesn't simply completely stop the damage being done to the body. Just the natural radioactive elements in a human body that's frozen will damage it over time. Cloning may also be of use in this approach, especially for those that have elected to only have their head frozen. While there's plenty of reason to be skeptical that this technology could ever result in resurrecting people, it's an interesting idea. And you have to ask, alright, you're legally dead for now, but not really, which would mean that the oldest still frozen cryonics participant would now hold the record for the oldest living person at currently 130 years old. should it ever be possible to wake them up. Number 8. The past is immutable. Think carefully about the nature of time. It's one of the strangest aspects of the universe. In one way, you could say that time is a continuum. It progresses from one event to the next. But think of another type of universe, where if there had not been tiny anisotropies or temperature differences in the unfolding of the Big Bang, the universe would consist of a kind of lattice of equidistant hydrogen atoms that never do anything. It would essentially be a timeless universe, where trillions upon trillions of years pass with little to nothing happening. Indeed, if the proton never decays, it would go on like that forever. Time in that context would be meaningless. But that's not our universe. Rather, our universe is one where the past defines the future, cause and effect. The effect being determined by the cause. That suggests that perhaps the past is immutable, and somehow still back there like a recording. Indeed, the Big Bang itself, the moment in which time itself began, still continues to define our universe. The question of whether the past continues to exist is a huge one, but in sci-fi it has led to many stories of time travel, from H.G. Wells' book The Time Machine to many modern interpretations that play with ideas of time, past, present, and future. You can find it from Star Trek to cult classic movies like The Fountain. But what does time viewed as a tangible thing really mean? Well, not the least of which is immortality. Think about it, if someone could travel back in time and visit a world of the past, then everyone in that past still exists in a very real, visceral way. Every bit as real as you and I are, and indeed, if backwards time travel were possible, we would be the past for someone else. In other words, as long as the universe exists, so does its tangible past in this interpretation, and thus, you achieve immortality in time. Number 7. Immortal from a distance. The speed of light is often seen as a limiting factor. So far as we know, you cannot exceed it. This is a greater problem than many people realize, because not only is it the highest speed an unimpeded photon travels at, it's also the fastest speed you can send information. The slowest time can dilate, meaning it stops, and also the speed at which it requires infinite energy to even reach if you're made of matter. Many things coincide at sea, and that's not a coincidence. But the effect of the speed of light on the transfer of information and how time operates is interesting. Einstein's theories of relativity show us that to a star system 500 light years away, you haven't been born yet. Yet you, your life, your experiences, and so on will not reach that point before you die. The entirety of the information of your existence, no matter how minuscule it would be propagating across the universe, due to the expansion of the universe, could travel forever. Meaning that while you didn't achieve digital or biological immortality, you did do it in physics. But what you can't know in this case is the history of your own world, because you can't ever catch up to light without infinite energy. You can never see the history of Earth, much less anyone after the history of you. In this case, functional immortality is an exercise of looking at alien civilizations as they once were. But the catch is, past a certain point, no one can ever look at themselves. The universe is a very strange place indeed. Number 6. Many worlds. Few ideas within theoretical physics are as outright odd as the many worlds interpretation. Essentially, this interpretation presents a situation where all that is possible to happen does, and results in timelines constantly splitting off from each other in a near infinite number of combinations. All that is possible to happen will happen in alternative timelines. This can range from the relatively mundane. One atom in your environment is in a different position in an alternate timeline, and that's the only difference. But it can also range to the radically different, where a very different human future results from the choices made before the branching of the timelines. Given that we may be very close to life extension and functional immortality right now, if we don't quite make it there within our lifetimes, there could be branch timelines where humans did make it past the immortality hurdle in time. This would mean that alternative timeline versions of you are immortal, but other alternative timeline versions of you are not. If the many worlds interpretation is correct, immortality, at least at this point in time, is the luck of the draw of whatever timeline you happen to be in. Number 5. Cyclic Cosmology. Physicist Roger Penrose has advanced a hypothesis that the universe is really just one iteration of a cyclic cosmology, where a Big Bang happens, a universe unfolds, and then at some point another Big Bang happens, and it just repeats over and over, perhaps infinitely. It may be the case that each of these iterations of the universe are different from each other, and there may have been past universes that didn't allow for life. At the same time, though, one of the potential ways to test this hypothesis is to look for evidence of the last universe's population of black holes in the cosmic microwave background radiation. If that pans out, then at least the most recent previous universe was close enough to this one to allow for the existence of black holes. But here's the kicker. If this idea is valid, then we don't actually know how far this goes. It could also be that each iteration of the universe is identical, with the identical timeline, with an identical you appearing over and over, living the same life, one iteration after the other, for eternity. In short, you may only be here for a short time, but you get to live again an infinite amount of times. Number 4. The simulation hypothesis. One of the spookiest areas of modern philosophy is the question of whether the universe is a simulation. On the one hand, the sheer bizarreness of quantum mechanics and physics might suggest that it's far too messy to be a simulation. But from the standpoint of human technology, we can see a day where at some level we might be able to create simulations of sufficient complexity to start looking like a universe of sorts. And then there is the overarching problem that if the universe is a simulation, there may be no way for us to tell. Simulation theory aside, however, there is also the question of data storage from the simulation. Is a record of the simulation made from start to finish, including that of your own existence? Can that part of the simulation be revisited by the simulator? A kind of rewind button where your time of existence is replayed for some purpose that lies outside the running simulation. If every aspect of your existence is preserved in such a way, so long as the record exists, you are functionally immortal. Number 3. Boltzmann Immortality. Infinite time is a strange thing. If you have it, then everything that is possible eventually happens. This led Ludwig Boltzmann to present a thought experiment. If that's true, then if you wait long enough in a universe of infinite time, then a thinking, conscious brain will randomly assemble, at least for a time. This is usually seen as a glimmer of consciousness every now and again in a dead universe. But when you're dealing with the notion that any possible thing will happen, then it expands. It may be that your own consciousness pops in and out of existence in infinite time, complete with your memories, and for all intents and purposes is you. Of course, this option also suffers from the same issue as digital transference of consciousness. What makes up you, as in your consciousness, may not translate to the random copy of your mind that may, or may not, pop up in an infinitely persisting timeline. But if it does, then it represents a kind of built-in immortality option in the universe itself, should time indeed be infinite. Number 2. The infinite universe. As with the possibility of infinite time, there is also the possibility of infinite space. We can only ever see a bubble of the universe, the observable universe, but we know that it extends further out, but by how much we have no idea. There is the option, however, that it extends infinitely, and that leads to the strange situation of if you travel far enough, you will come across an almost exact copy of Earth, and even you, or possibly an exact copy for all intents and purposes. But what's not often pointed out is that it need not exist at the same time. In an infinite universe, a variation could happen where a copy of Earth appears 30 billion years later than this one, or at any point really. It is, after all, infinite. This represents a sort of immortality. Once your time is done, it's done. But there may be copies of you that appear throughout the habitable history of the infinite universe. Number 1. The Poincare Recurrence Theorem. There's no question that hidden within the realms of mathematics and physics, there are many strange things. counterintuitive to the world in which we live. Everything from quantum non-locality, spooky action at a distance, photons that do not experience time, and a barrel of others that are yet to be fully rectified with what we view as reality. One idea hidden in here is the Poincare recurrence theorem. Formulated by Henri Poincare in 1890, it essentially boils down to this. In mathematics, certain systems, after you wait a long enough but finite time, will return to their initial state. In other words, history effectively will repeat itself, so long as the theorem applies to the universe itself, which is an unanswered question. The related Poincare time is the interval of time that it takes to do that. But that's the big problem. The Poincare time is very likely to be so long that the universe may simply go through another Big Bang and create a new universe before it ever gets back around to everything returning to a previous state. Or maybe we might exist as a result of the Poincare recurrence theorem, and we are just a return to the universe as it once was, and will be again. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently concerned about ending up immortal twice. Not good. And that just seems like a lot of work. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.